All right, so in this video, we're going to go through sample question 8 from the Society of Actuaries ExamP set of sample questions. If you haven't tried this out on your own, I suggest doing that before watching this video. So the question reads, among a large group of patients recovering from shoulder injuries, it is found that 22% visit both a physical therapist and a chiropractor, whereas 12% visit neither of these. The probability that a patient visits a chiropractor exceeds by 0.14 the probability a patient visits a physical therapist. Calculate the probability that a randomly chosen member of this group visits a physical therapist. So, let's see. Again, it gives us a lot of information, and it's probably can be condensed into just a few lines of things. So, what does it say? It's found it's found that 22% visit both a physical therapist and a chiropractor. So that is an intersection, right? So the probability that somebody visits a physical therapist, so I'm going to write that as PH, and a chiropractor, CH, well, that's going to be 0.22, 22%. Whereas 12% visit neither of these. So the probability of not visiting a physical therapist, so PH prime, and not visiting a chiropractor or complement, right? That's equal to 0.12. Okay, and then it says the probability that a patient visits a chiropractor exceeds by 0.14 the probability that a patient visits a physical therapist. Okay, so let's write that out. The probability that a patient visits a chiropractor, the probability that they visit a chiropractor exceeds by 0.14 the probability that they visit a physical therapist. Right, so setting this up should be fairly simple. It's from way back, algebra 1, right? Or, just the first part, whatever you did in like 8th grade or something even. So let's see. We want to calculate the probability that a randomly chosen member goes to the physical therapist. So the probability that somebody goes to the physical therapist. Now, this might seem confusing at first. Where should I start? Right? Well, I think we can figure out something here by drawing a picture. I'll say it a lot, but I think things are much easier to understand visually. So sketching something out to help you is always a smart idea. So we're given that 12% visit neither of these, so this outside box will be 0.12. Now there are two options. You can go to a physical therapist, PH, or a chiropractor, CH. And the people that go to both of these, 0.22. Okay, and this is visually the information we have. What are we looking for, though? We're looking for this right here. Okay. Now, here's the thing. We can figure out the probability that somebody visits a physical therapist or the probability that somebody visits a chiropractor, which would be all this information, like these two circles here. And that would help us out a lot. So that's going to be our next step. Two ways to kind of do it. One way is kind of visually, you can see, okay, so everything on the outside is 0.12. That means everything on the inside must be 0.88. Although I do believe it's important to understand some of the more formulas and algebraic ways to go about this. So I'm going to talk about something called De Morgan's law as well as this negation. This was something from a previous problem. I remember it was used. I don't remember which specific problem though. So let's look at this piece of information. De Morgan's law says if I have something like this, A and B, or A or B, right, and I'm trying to negate the entire thing, Well, what's going to happen is when I open up the parentheses here, both things get negated. So this becomes the negate, like A complement, B complement. And whether it's an intersection or a union, that gets changed to the other one. So this is an intersection, it's now a union. And those two are equivalent, right? Another thing is that if you have the probability of event A plus the probability of the complement of event A, so basically you have A and then not A, that should equal 1, right? That should be your entire sample space, your total probability. So I can use that here, right? So taking the probability of somebody going to a physical therapist and a chiropractor, or somebody not going to either, sorry, and negating the whole thing, what that's going to get me is the probability that they go to a physical therapist or a chiropractor. And then what this thing here says is that if I add these two up, I should get 1, right? So 1 should be equal to the probability of going to a physical therapist, or sorry, probability of going to neither a physical therapist nor a chiropractor, plus the probability that you go to one of the other, right? Probability of a physical therapist or a chiropractor. That should equal 1. And since this is 0.12, you can subtract both sides, right, and get 0.88 equals the probability of going to a physical therapist or a chiropractor. Now, it might seem like this one is a much shorter, kind of method, and for many of you it may be. In my opinion, for this particular problem, they're equally the same. I just wasn't, going as much in depth into this explanation as I was this one. That's why it seemed like it took longer. Okay, but now with that kind of out of the way, let's use what we have. We have this union, right? What we're looking for is this, pH. So the probability, and this should be something very familiar, right? This particular formula, probability you go to a physical therapist or a chiropractor is equal to the probability you go to a physical therapist plus the probability you go to a chiropractor minus the probability you go to both physical therapy and a chiropractor. And we have kind of formulas for most of this information, right? We can replace this. So this is going to be 0.88. We don't have this. I'm going to leave this as physical therapist, right? Because that's just a question mark. Probability that somebody goes to a physical therapist, which is what we're looking for. So obviously it'd be weird if we had that automatically. And we don't have a set value for probability of going to a chiropractor, but we do have a formula we can substitute that'll make our lives a lot easier. Probability that you go to a physical therapist plus 0.14, and that should be in parentheses, right? Even though it's not going to matter in this case. Subtracted by the probability that you go to both, which is right up here at 0.22. All right, so now let's just solve this algebraically, right? After this setup, this is all an algebra problem. 0.88 equals, and then opening up this parentheses, it's now 2 times the probability of going to a physical therapist. And just to make sure I don't make an embarrassing mistake, like arithmetic mistake, I'm going to use a calculator for this. And just make sure, okay, negative 0.08 would be 0.14 minus 0.22. Now what I can do from here is add 0.08 to both sides, and I'll get 0.96. Right, is that right? Yeah, it seems right. 0.96 is equal to 2 times the probability that you go to a physical therapist. And then I can divide by 2 on both sides. And the final probability is 0.48 for the probability that somebody goes to a physical therapist. Okay. Now, normally this problem would go a lot quicker. It's just, again, I'm explaining things. I'm trying to be thorough, right? So your final answer is D. Okay, main takeaways from this problem, right? What can we learn from this to make us better? We know that we're given a block of information, and all we did is turn it into 1, 2, 3, and then 4 lines, right? And then this fifth one is just the question that it's trying to ask us. We know that being able to turn things into charts, Venn diagrams, or graphs, or something visual makes our lives a lot easier, right? It makes things a bit easier to understand. And then what's important is to kind of know what's going on underneath, right? The diagram makes things easier to understand, but what was happening? Well, De Morgan's law, right? That comes up. This is, I think, if you're going sequentially through this packet, I think it's like the second or third question it might have come up in, as well as this idea of the probability of an event plus the probability of the complement of that event should be equal to 1. Okay? So hopefully that was a kind of thorough explanation that made sense. If you have any questions, throw it down in the comments. I'll answer them to the best of my abilities. If you want to see some more worked out questions, I should have a playlist with more ExamP sample questions. If this video helped you out, hit the like button because that definitely helps me out. But other than that, good luck, guys.